Okay, this is the pre-calculus, the financial math, exponentials and logs, the test review. I want to give some of the solutions to this here. So there was a beginning problem about finding your dream home. The purchase price was given, financed over 360 months, which is typical for a mortgage, 30 years, and then the 3.75% rate, which will be compounded monthly. So part one was to find the monthly payment. So there's kind of a messy formula to use to do that, or you can just use the app on your calculator, which is what I was going to use. So if we go into the calculator screen and apps here, the first one is the finance one, and there's a TVM solver, and that one kind of lets you put in information and find one missing piece basically. So I have everything in. Let's pretend like this payment is unknown. Oops, that was the purchase price, 265. 2, 3. The payment, let's say, is unknown here. Okay, so just running through real quick, the N is the total number of payments, that's 360. Notice that's different than the lowercase n we use. For monthly, we would normally use 12. This is a capital N here. This is the total number of payments. So it's the 12 months for 30 years, so 12 times 30. The interest also, we don't move the decimal when you use the calculator here. See the percent sign is already written there. So we just leave it as the full 3.75. PV is going to be your present value, how much you currently owe, which is the purchase price. We're going to find the payment in a second. Future value down here, we want to get our payments down to 0, and then the PY and CY is payments per year and compounds per year, and so that's kind of like what the lowercase n was for compound interest problems. That's the 12 times per year. So what we're going to do is highlight the one you want. You got to do alpha, enter, and it will solve for it. So that would be your monthly payment, about $1,227.26. Okay, so $1,227.26. Okay, now we want to get a recursive formula for our balance each month. So what you might want to do, let's take a look at C actually and get the pattern going here. And then the recursive formula will kind of follow from that. So the way I think about this, there's really only two things going on here. Let's set up a little table here. As months go by, and then the balance owed. Okay, so to get started after no time has gone by, after 0 months, you owe the full value. Okay, and then again, I'm saying there's really only two things that happen. Okay, as time goes on, as 1 month goes by, okay, they're going to do two things. They're going to add some interest, but you are also going to make a payment. Okay, so that's going to change how much you owe. So to get the interest, what you're going to do is take the balance from the previous month. Okay, we're going to multiply it just like a normal compound interest problem. It's always 1 plus the annual rate. Okay, and this time it was getting divided up into 12 for each month. Okay, no exponent here because this is really just to the first power. It's just for 1 month. But then we are also going to subtract our payment from that. Okay, and doing the calculations here should get us our balance here. If you want to do a little simplification and maybe figure out what this is, just don't round it off. I would actually leave the full value, but this you should find out turns out to be 1.003125. Okay, so this is the calculation we're going to end up doing here. Okay, and that will get us our balance then after the first month. Okay, and that got me a value of 264,600, and I'm going to round it, it's 0.865, I'm going to round that to 0.87 because this is dollars and cents. Okay, so this is how much you would owe after 1 month. Okay, and it seems reasonable. We started out owing 265,000. Again, think about, we made a payment. We actually made a payment of $1,200, but because interest was added, the balance down here is not $1,227 less than it was originally. It's only about $400, a little less than $400. So that means a lot of our payment went to interest in the first month, and that's typical for mortgages and anytime you finance something. Okay, let's do one more. If we do month 2 now, it's going to look a lot like what we did in month 1. The only difference being that this value now is what we're going to get charged interest on. Okay, that's how much we currently owe. So I'm going to take that value, 264,687 cents, it's going to get multiplied by the interest, okay, or the growth factor due to interest, which is the same as it was in the previous spot. And we're still making the same monthly payment here. Okay, so if we calculate that out, this will tell us how much we owe after 2 months. Okay, and I'm getting around $264,200 and about 48 cents. Okay, so that's going to be our balance after month 2. So again, notice from month 1 to month 2, that number went down by about, it went down roughly $400 again. Okay, from the highlighted in blue to the highlighted in green was only a change of about $400. Because again, most of your payments at the beginning are going to interest. Okay, so if we can kind of look at what's going on here to get the recursive formula. Okay, so let's say, you know, a bunch of time goes on here and I want to know what's going on, what's the pattern here. So what really happens is to get, let's say I want to know the nth month and I want to know how much do you owe after that. Okay, u sub n, which is basically, it's just this fancy way of saying the y value there. It's going to equal the previous month. Okay, so that n minus 1 is a subscript. So for example, if I wanted this to be a 10, if I wanted the 10th month, I would need the 10 minus 1. I would need the 9th month's value. Okay, because you're always using the value right before the one you want. Okay, and again, now you're only doing 2 things with it. You are multiplying it by that interest growth factor, which was 1.003125, and you're subtracting the payment. Okay, and this will be the recursive formula. Okay, and again, recursive is something that uses the previous value to get you the next value. Okay, so this is okay. I mean, it helps see the pattern, but it's not going to help you get any specific month unless you happen to know the month before it. Okay, so if we look on the review here, oops, wrong page. We just did part B. Okay, we just did the recursive formula. But like down here, if I'm looking ahead, if I want to know how much do I owe after 120 months, that recursive formula is not going to help me because I would need to know how much I owed after 119 months, and then I would do the calculations to it. Okay, but to actually get that value, to do part E, we're going to need more of an explicit formula where I can just plug in 120 somewhere and do that. Okay, so I think we took care of part B. Part C, we did month 1 and 2. You could do that one more time to get or to get the 3rd month. But let's look at finding this explicit formula now. Okay, the form's going to be given here. Okay, this one it's kind of like it's an addition and it's a multiplication, so it's kind of like the combo of arithmetic and geometric. Okay, so it has 2 values we need to find. I need to find the a, which is what we're adding, and I need to find the b, which will be like the coefficient on the multiplication part. Okay, so let's look at that. So the general setup, just didn't want to move that down. Oh, well, we'll just leave that there. We kind of said the general format for the explicit is sum A plus sum B. The R is the same as it was before. That was basically what the rate worked out to be, and to the nth power. Okay, so we need to find A and B. Okay, they're not the same A and B as a general exponential. A is not the initial value, and B is not the growth factor. They just use A and B. They're just real numbers. Okay, so what we need to do, what you need to recognize is since there are 2 things to find, you're going to need 2 equations. Okay, we're going to use a system of equations to do this. So the system of equations will come from the table. Okay, so it's kind of a good thing to have the table started anyways. So what I'm going to do, I'm going to encourage you guys, it's going to be easiest or best to just use the first 2 rows in the table. Okay, I'm going to use this as a point, as an n, and then a u sub n, or like an x and a y kind of thing. And then I'm going to use the second row in a minute here too. Okay, so let's do the first one first. So the first one, okay, so think of this as like a y equals or something like that. So the y value initially was 265,000. It equals sum A that we don't know, plus sum B that we don't know, times that growth factor, And the exponent, that was after 0 months. That was the n there. Okay, I'll do the same thing now with the second row. Okay, its y value, and I'm sorry, the one was the x value, sorry. The y value was the 264,000 that we owed. Okay, so let's set that one up. Okay, it's 264,000. 600, sorry, 264,600 and 87 cents. Okay, that's going to equal, again, some A that I don't know, plus some B that I don't know, times all of this. But now that one was after 1 month to the first power. Okay, so we have a system of equations to solve here. Okay, going back to algebra stuff. Okay, so it looks a little messy at first, but what you should notice is that this, okay, anything to the 0 power is really just 1. So in that first equation, the b is really just getting multiplied by 1. Okay, so basically, this whole piece right here doesn't even really need to be there because it's just like multiplying by 1. And also in the second equation, I don't need to write a 1 there, you know, because the first power exponent doesn't do anything. Okay, so let me also just reorder the way that the second one's written. I'm just going to change the b and where the number was, just because we're used to having the coefficient come out front. Okay, so that's the same thing. I just switched the order there. Okay, so now we have this system. If we can go ahead and find a and b, we will have our values, and we can write our explicit form. So what I think might be easiest, some of you guys might like elimination. I kind of like substitution. Like for example, I would take the first equation and subtract b from both sides. And I would get this new equation, 265,000 equals a minus b. Oops, I wrote that wrong. 265,000 minus b equals a, right? Because those b's canceled out. So 265,000 minus b is going to equal a. And now that that's solved for something, what I can do is take this, which equals a, and I can go ahead and plug it in for a into that equation. Okay, so this is substitution method. Okay, so rewriting, let's say that's equation 1, that's equation 2. Rewriting the second equation, 264,600.87 equals, now I'm going to replace a with 265,000 minus b, and I still have this plus 1.003125b. Okay, so make sure we see the connection there. A just became this, okay, from when we solved the equation to begin with. Okay, now we'll just do a little bit of algebra. We can combine some terms here. 264, 600.87 equals 265,000. If I were to combine, remember that's a minus 1b, and that it's going to end up being a plus 0.003125b. Okay, then we'll go ahead and subtract the 265,000. And we're going to get, once we do the subtraction there, 264, 600 minus minus 265,000. We are going to get a negative 319.13 equals, those cancel, 0.003125b. So dividing both sides by 0.003125, I'm going to get a b value of a negative number, 127721.6. Okay, so that's b. All right, and then we could go back now and find what a is by using this equation. Okay, so 265,000 minus the b value we just got. You can take a second, we're minusing a negative, so it's really like adding. And a ends up being 392.5. 2,721.6. Okay, so we know A and we know B. We can now write our explicit form. Okay, and we said it's basically just like y equals A plus B, but it's a negative, so I'm gonna do a minus times the growth rate to the x power. Okay, that would be your explicit form. And that would allow you then to find the 120th month um, by just plugging in 120 for the exponent on that. Okay, so if we do that real quick, let's see what we got here. I'm actually going to do it in the y equals just so we can verify that everything's working here. So the a value was 392,721.6 minus 127,721.6 times 1.003125. All right, so a lot of numbers here. I'm going to raise it to the x power, and I'm going to let the table do this for a bunch of different values. Okay, so going to the y equals table, if we go back to where we started, this should be a way to kind of verify that your explicit formula is correct. You know, make sure that those y values are the same as the ones we got when we did this initially. Oop, didn't want to go that far. So it looks like at 0 we owed 265. That was the one we did when we did the recursive pattern, right? And then what I could do is just follow this table down into 120 months, or the shortcut is go to the table settings and just start at 120, and then go back to the table. Let's see if, and that should be your answer for that question about 120 months. Okay, so we would still owe over $200,000 after 120 months. So that's what I was looking for in part E. Okay, so a lot of work there. But again, just try and slow it down. I mean, there's really only two things going on. You're adding your interest and you're making a payment. Okay. All right, number two. Your friend purchased a new home as well. $220,000 is an initial value. It's depreciating. Okay, it's decreasing in value by 3%. Okay, so we could say something like an exponential equation would be the new value y. Remember, the format's always the initial or the starting value. Okay, we usually do 1 plus when things grow, so it's 1 minus when things decay. So 1 minus 0.03, and it's happening in 5 years. Okay, you could also just do the calculation, make this just a 0.97 to just to simplify things a little bit. And you should get an answer there of around, oops, I think I missed a 0. It's 220,000 in there. Let me fix that up real quick. 220,000 times 0.97 to the fifth. All right, I'm getting 188,921 and 49 cents. Okay. All right. So part B, write and solve using logs an equation to determine how long it will take. So I want the ending value to get down to 150,000. So that value is going to go in as a y value. Okay, and we are going to solve for the variable here. Okay, so let's write the equation. Let's get a little more space here. So 150,000 equals 220,000 times 0.97 to some power. Okay, so your first step in doing all these is get the start getting the variable by itself. So get the exponential by itself. So I would always divide by the initial value. Get rid of that guy. Okay, 220, 1, 2, 3. So if we do the division there, I'm getting around 0.6818. Okay, and that pattern kind of continues. So carry at least 4 decimal places. Okay, and now we have a variable in the exponent. So what I would suggest doing is go to your log form. So switch to log form, and then we can use our calculator to finish it. So basically it's going to be log, the base is the thing getting raised to a power. Okay, the thing we're taking the log of is over here. And remember, logarithms always equal the exponent. Okay, so we will do that on our calculator. You can do it two ways. You can either go log base, okay, or you can do it as the division problem. Log of the 0.6818. This is that old change of base formula we talked about. It's the log of this guy over the log of the base. Okay, so if you don't remember the log base on your calculator, you got to do the division problem. And make sure you have the parentheses where they are. It's very important, especially in the numerator there. Make sure you're closing up the parenthesis. And I'm getting an answer of around 12.6 years, roughly. So I'm going to say approximate because I rounded, it was 12.57 something. Okay, and that would be in years. Okay, moving along here. That was number 2, parts A and B. Number 3, other friend plans to invest. Okay, here's a compound interest problem. Okay, usually you'll see the word investing and you'll say into an account earning interest. So we want to find the balance after 8 years if it's compounded monthly. Okay, so the amount, or Y or A, whatever you want to call it, is again the initial amount. Okay, 1 plus, because it's growing. Here's my interest rate. We need to convert that. This time it is being compounded monthly, so it's happening 12 times a year. And it's happening for 8 years, but 12 times every year. So that's why it's n times t in the exponent here. Okay, and just make sure on your calculator you're being careful with parentheses and everything. So I'm getting an answer of around 24,666 cents. Okay, so again, be careful with parentheses and exponents and all that kind of stuff. Okay, part B wants us to do a similar problem, but what if it's compounded continuously? Okay, so that's one special case where, again, if it's happening continuously, we don't really know what's used for n, or we would want to use infinity, but we can't really do calculations with infinity, so that's the case where you use e as the base. Okay, so in this case, the y will be 15,000 times e to the rt. Okay, so that's the one other little formula. And honestly, this answer should be pretty close to what we got before. But it's just going to be probably a tiny bit bigger. So doing the calculation, I got $24,632.09. Okay, so it's a little bit bigger, $32 bigger, I guess. So, okay, all right. How about C? If we're compounded monthly, how long is it going to take to triple our money? So it's kind of similar to part B. They're telling you they want the end value to be triple what it was before. Okay, so we started with 15,000, so to triple that, I want to have 45,000 at the end. And that's going to equal 15,000, 1 plus the rate. This one was, again, monthly. And it's 12 times. And our issue is how many years will it take? There's our variable up there. Okay, so again, I would start out by dividing out the initial value. Okay, so divide both sides by your 15,000. And you should end up seeing that this, when you divide, is going to become a 3. Okay. I'm doing a little calculation here to do this first. That number turns out to be 1.005167. I would round that, but carry it out, again, a decent way here. And that's to the 12x power also. Okay, so that's just the doing the calculation on the inside the parentheses. Okay, and you don't have to do that. You could leave it as a fraction if you wanted, but I think most people find this a little easier. And then we finish this out just like the other one. Here's what I want. I'm going to go to log form. So it's going to be log. The base is that 1.005167 of 3. It's going to equal the exponent. Okay, and then we would finish that out on the calculator. again, doing the left side if you want to do the log base little trick that we did in class, or you could do a division problem. But I'm getting for the left side, just straight from a calculator, around 213.1698. Okay, so I'll round out there. That equals 12x. I'm just going to leave that whole number in my calculator though and divide by 12 to get x. So x is approximately 17.8 years. Okay, so that is solved using logarithms. Okay, and then the last few, just a couple of brief equations here. There's a couple ways to do these. If you notice something like in number 4, both sides could be like 6 to the power, you could do the same base thing. I'm actually just going to go ahead and do them like with logarithms, though. I would just convert this to log form. So it's log, the base is 36, because that's the thing getting raised to a power, okay, of 216, and it equals the exponent. And we would do the same exact kind of thing we were doing just a second ago, right? Do the log base 36 of 216 on your calculator. That one should be about, it should be exactly 1.5. Okay, add the 3 over, divide by 2, I'm going to get a p-value of 2.25. So a couple of algebra steps there that I'm not going to spend the time on. Okay, but that's number 4. Okay, number 5. Okay, a little bit messier because there is variables, or there are exponents on both sides, right? So if we set number 5 up, it's 125 to the negative 3n equals 25 to the 2 minus 3n. Okay, so what I would do this one we can't just change it to log form, okay, because both sides have an exponent on there. So this is one where you actually have to take the log of both sides. Okay, so I'm taking the log of the left and the log of the right. Okay, so I basically, at this step, all I've done is like written the word log there. We're going to then use a little property we talked about in class. Since a log itself is an exponent, this is kind of like having an exponent there to another exponent. And if we remember, when you do power to a power, it turns into multiplications. Okay, so these exponents can now be brought out front, and you're going to get negative 3n times the log of 125 equals 2 minus 3n times the log of 25. Okay, and now what you can do is you can you want to convert the logs into decimals if you want to, you can. The log of 125 is around 2.0969. Okay, if you don't want to do this step till later, that's fine as well. From a calculator, the log of 25 is 1.3979. Okay, and then it's just going to turn into some algebra steps here where you will multiply these, distribute over here. Okay, and that will solve it. So let me do that. Okay, so if you want to take a look at some of the algebra here again, just in the to save a couple minutes, I skipped ahead in the video. So there's the steps there. We basically distributed, combined some like terms, and then solved for n algebraically. So feel free to pause and look at that. Then your last question, number 6. Let's see if we can get that up here. Says 7 to the x minus 6 equals negative 3. So that one again, I would just, I'm sorry, that's a 6 there. I would just add the 6 over. So we're adding 6, so that's going to become a 3. So 7 to the x equals positive 3, and then just go log form on your calculator. It's log base 7 of 3 equals x. Okay, and we'll just show on the calculation on that just as a quick refresher. You can go to your math button and scroll through the list. There's a log base, and we wanted it to be log base 7 of 3, is that right? Yeah. Log base 7 of 3. And it's basically saying what power do I have to raise 7 to make it 3. So the answer, there's your answer, about 0.56 roughly for that one. Okay, and that solves the original equation. You can see if you were to check here, if you were to put the 0.56 in right there, You would be taking 7 to that power, and it would be equaling 3.